Good morning, ladies and gentlemen. It's a great pleasure for me and a great honor for me that I'm allowed to tell about building of intelligent transport systems. And in fact, I'm telling about intelligent road transport systems. So when I saw this conference is an IT conference, so I thought that my speech will be very brief. Simply put together computer, some software platform, traffic algorithms, and then you are ready. We'll have software platform, such as Java or .NET or traffic algorithms. You will find some professor in the university who will provide you with traffic algorithms, and then you are ready. All my experience of 20 years in traffic management says, don't do it this way. Let us put the cart before the horse. Just start with the end. Imagine you have already built and installed an intelligent transport system. What now? Now we as Berthold, we are ready, we go home and you are running the system and nothing happened. No. You have to run the system. You have to take care of operating, of services. You must have to take care of organization and all this with special goal settings. And the first one is you have to provide high quality of traffic performance. And you have to run the system cost effective. I don't know any administration who has enough money to let you do what you want. You must look at the costs. The system should be developable and maintainable. What does this mean? You must enable evolution over time, over years. And maintainability in technical sense is the ease with which a product can be maintained in order to meet new requirements. They will come over the time to make future maintenance easier, to cope with changed environment. All this will come over the time. And so in the next slides, I will show you some crucial aspects of building of ITS, how one can solve these challenges, and I give you some hints to appropriate architecture and some special ITS chain challenges. And I will show you a successful solution and how we as Berthold build such a system. So we start and say, put single, isolated, but optimized systems. No, not this way, and it's similar like in the first speech from intelligent integrated systems. One center with one software should be installed, and then you can install the infrastructure over the whole network. This can be local traffic management, rerouting system, road weather information systems, all different ITS measures. Maybe you will install some sub-centers in the region. It's not necessary, but it can be done. And why and what are the opportunities to do it like this? I will give you an example. If you have a central data management, you can use all the detector data in multiple ways. For example, for local traffic management, but the same data you can use for national rerouting or for the generation of traffic messages, RDSTM, CTPAC, or for statistics and for forecasts. But you need, therefore, a central data management. This is the example of the system architecture for automatic detection and control. On the bottom line, you see the infrastructure side. detection, variable message signs, loops, cameras, weather stations, fog eyes, all is installed there. And on the top level is the traffic control center for a nationwide traffic control center. And there's the intelligence for the traffic management system. In content-related structure, this means you have to structure the system from monitoring, that is the deriving of traffic status, up to information traffic control optimizing. And this is worthwhile in own course of lectures. We don't have time enough to tell it here, so I recommend to look at our website. You will find it written down, and you will have time to study this. The IT architecture, because we are talking on this conference about IT, is you should the architecture should be a service-oriented architecture based on SOAP web services. Why? First thing, it is very easy to scalable the system if these services are stateless. So sometimes we start with 5, 4, 6 computers and end up with a system in Austria with 100 computers. And if the software is not prepared to enhance the system, you can't do it in this way. And you can integrate in an easy way individual components so that the system will fit to the customers and customers' requirements. But our experience says that there are special ITS requirements and features, and one is we propose a hybrid architecture. So via the service bus, for example, of an enterprise service bus, you can integrate the services. But via the service bus, you can integrate data-centered modules. You have a lot of data which will come normally in cycle, all at the same time, with the same timestamp, and it is very important that you analyze data with the same timestamp. It is not from 11 o'clock, this is from 10:45, and this. So all data must be from one timestamp, and if you think that you can gather data in 50 seconds or less, then a lot of data will come at the same time, and this data bus will serve that your system will be performant enough. These are only some hints. Another special ITS feature is the georeferencing. It is absolutely an essential functionality in ITS systems. You can install it as a geodata service if you use this service-oriented architecture. And this geodata service, for example, has to convert the different reference systems. You have metering or mile posting, RDS TMC location, TPAC location, OpenLR to communicate with cars, or positioning of moving cars with vehicle-to-vehicle communication, vehicle-to-infrastructure communication. The cars present their position in WGS 84. And we found out that location referencing via on-the-fly map matching will solve a lot of problems which we had before. So the configuration process will be much easier. So if you have to install, new cards, new digital road maps, and you have objects configured into this in this digital roadmap, you have to put this in the new roadmap, and this can be work of months. And if you use the on-the-fly map matching, you can do it in 1 week or less. And it is very important to interface with external systems. Yeah. Years ago, it was a must that everybody uses the same digital road map, and nowadays you can't force this, that everybody uses the same map, so you have to interface with different georeferencing systems. Coming back to the goal settings. One was cost effective. If you have one center, you will have only one equipment, one human resource, where you can run your system in a 24/7, 365 way. And it's absolutely necessary to run it in 24/7. And you have only one place, of course, less human resources necessary. The high quality of traffic performance. If you run a system, traffic management system, you have to optimize the parameters. You have to optimize the algorithms. And this, it is an advantage to do this in one place. So we have once the experience. You are doing once the experience. How to optimize, and all traffic control systems over the road network are working with the same standard. The third thing was developable. The system should be developable. It should be able to evaluate the system. So you can start with the first installation. Then you learn, optimize, enhance the system on the basis of this architecture, and then you can extend the infrastructure over time, independent of new software developments. See, the essential is the know-how concentrated in one place. To give you an example of a nationwide traffic management system, we developed and installed the Traffic Management and Information Center for Highways and Expressways in Austria. The operator is Jasvinak, and they are responsible for more than 2,000 kilometers of highways and expressways. To give you some figures, we integrate in this national Traffic Management Center 10 regional sub-centers with 1,300 detection sites per direction that are 4,000 sensors, almost 3,000 gantries carrying almost 7,000 variable message signs. And there you see there's a very big system. All data is coming every minute, sometimes in tunnels every 50 seconds. And the archive is going per day almost 8 gigabytes. And we have an archive of more than 2 terabytes, 2.3 million gigabyte data in the archive, which we can analyze in every moment. And this center integrates also the data from all tunnel centers. It's very important just in Austria. And the system covers the whole functionality of traffic, of an ITS system, traffic management, from prediction, actual and predicted traffic situation, traffic control, traffic information. The radio operator is part of the traffic management center, for example. We support roadworks management system with the traffic analysis system, so that you can say in which roadworks will have which influence on the traffic, and you can optimize the roadworks. We exchange data with other countries, Italy, Germany at the moment. And there's a whole message management. That means all messages from traffic messages or some malfunctioning of system and so on are managed from the system. And this is a result, and these are global figures, but you can achieve about 30% of less accidents and especially, and then also 30% of less insured persons. We as Bielefeld built a system on basis of our core system Geodyne, together with some mature components, into a new customer-oriented system. Within this Geodyne, there's our experience of 20 years in traffic management. And Geodyne, very interesting name. Geo stands for the handling of geographic data, and dynamic is the handling of the dynamic mass data.
The last minute.
That's good. Last slide. Why did Jasvinak choose HB? And I mention HB because we as HB, Bielefeld, are partner of HB, Hewlett Packard here in Slovakia. So we had a lot of experience in planning, developing, and successful operation of traffic management centers over 20 years. We can handle all this mass data in time. Yeah, we have special traffic engineering know-how. These are not only informatic and scientific computer scientists, but also traffic engineers with us. And we have the ability to integrate new technology, which is essential if you operate such a system over time. For example, we also integrate a cooperative traffic management system cooperative traffic management data from car to car, car to infrastructure communication. As I promised, it was the last slide. Thank you very much.
Thank you very much, too.